You know we have our favorite 3D printer build surface, but there's a catch. They don't make them to fit all of our printers. Specifically, our lightning-fast round-bedded FS on S1 Pro or the tiny Sovol Zero for that matter. So what do you do when you have a budget desktop CNC router and a thick sheet of hardened spring steel? You try to cut it yourself. Spoiler alert, slot milling hardened steel on a budget machine was a spectacular disaster. But you know our motto, we make mistakes so you don't have to. Stick around to see why being too gentle actually caused our CNC to fail and how we ultimately came out on top. Here's the proof. We show you the complete process that you can replicate with a budget CNC like our Acme Escarva 4S to create the absolute perfect custom-sized BQ CryoGrip plate. This is gerGO, and welcome to gerGO Print 3D, the YouTube channel where my little nephew Levi and I tackle fun projects, explore amazing devices, and occasionally try to push our machines way past their limits. As always, this video includes curated, translation-ready subtitles, detailed chapter markers, and audio tracks in multiple languages to give you the best experience. Before we start endangering tools and making sparks fly, I need to introduce you to an incredible manufacturing partner and the sponsor of today's video, JustWay. They specialize in on-demand manufacturing like sheet metal fabrication, injection molding, and industrial 3D printing. In fact, we are already working on a crazy project with them. My father's lab equipment repair firm was asked to fix an old test tube centrifuge. The machine is over 20 years old and works perfectly, but the plastic swing-out rotor that holds the tubes is deteriorating. The original manufacturer no longer sells replacements, and even when they did, a single replacement cost over $600. So I designed and 3D printed a prototype out of ABS to check the fit and tolerances, but spinning plastic at thousands of RPMs in a lab setting is a terrible idea. So we uploaded the model to JustWay, and they are currently using SLM technology, selective laser melting, to 3D print that exact part for us out of solid aluminum. We cannot wait to show you that project. If you have a functional prototype that needs to be turned into real industrial grade metal, check out JustWay using the link in the description below. Alright, back to our build plates. You might remember our ongoing battle with bad adhesion on the Cobra 3. We actually paid for our first BQ CryoGrip glacier plates for our Cobra 3 and Bamboo H2S with our own money. And the results were phenomenal. I actually tore up one side of that Cobra 3 plate in an earlier video because that very first print stuck a bit too well. After seeing that, BQ reached out and kindly offered to outfit the rest of our printer fleet with these amazing plates. But there was a problem. They just don't manufacture plates for every printer out there. If you remember our recent video where we printed the updated statue of Levi, we forced to take a square CryoGrip plate and awkwardly wedge it diagonally into the round bed of the FS on S1 Pro just to make sure the tall print wouldn't fail. It worked, but it was sketchy, and we definitely couldn't use the printer's full build area. But looking at the Acme Escarva 4S CNC router sitting here in the entry hall, the furthest point of my apartment due to its noise and messiness, a wild idea started forming. Could we take a larger square sheet of spring steel and literally carve out the exact shapes we need? BQ sent us an awesome care package to find out. We received a 350mm Voron 2.4 glacier plate, a Voron 2.4 frostbite plate, and a 256mm Elegoo frostbite plate. By the way, if you are wondering about the difference, the frostbite is fantastic for PLA and PETG, while the glacier is the more versatile option that can handle higher temperature materials like ABS, ASA, and even engineering filaments as well. The sizing actually works out great for our fleet. If we can get rid of the little protrusion on its top, the 256mm Elegoo plate will become a perfect drop-in fit for our GDQ1 Pro, the Cobra 3, and even the Creality Hydo. That one already came with an epoxy resin plate offering amazing adhesion. Meanwhile, the massive 350mm Voron plates are good enough fit for our Sovol SVO8 and the Creality K2 Plus. But more importantly, a 350mm square is easily big enough to contain the 330mm round shape required for the FS on S1 Pro with its Delta motion system. Now, cutting a piece of spring steel sounds simple enough, right? It's only about a millimeter thick. Wrong. Spring steel is incredibly hard, and the budget desktop CNC router will absolutely struggle to cut it. But the Escarva 4S still tempted us with its large enough work area to fit the plate, and as always, Levi and I were ready for adventure. We jumped onto AliExpress to do some shopping for the toughest bits we could find for cheap. We settled on a 2-lie 4mm 2-flute end mill coated with HRC65 carbide. Can you believe these cost less than $6? We also grabbed a 4mm collet that fit the upgraded 500-watt spindle we installed on the Acme router in our previous video. Before tackling the massive round plate, we needed a test project. We decided to make that 256mm Elegoo frostbite board fit our GD-Tech Q1 Pro, Cobra 3 and Creality High perfectly. We brought the measurements into Fusion 360 and set up our origin and stock. We added our new carbide bit into the tool library and set up our heights and passes in a 2D contour job. Since we are pushing the limits of this 500-watt spindle, our instinct was to use incredibly conservative settings. We dialed the spindle down from its 12,000 max to 8,000 RPM, set a 250mm per minute feed rate and a 50mm per minute plunge rate. Used a microscopic 0.05mm step down and a gentle 1.5 degree ramping entry to prevent the bit from plunging straight into the steel. Looking good. Well, don't always trust your instincts. If sharing our full engineering journey saves you from breaking a bit or tearing your hair out, please take a moment to hit those like and hype buttons. It really helps the channel out. You can tell we were really cautious, doing a few dry runs, hovering above the bed, and then did a tiny 10mm test cut using plenty of cutting oil. It sounded good, so we let the machine run the full 80mm production cut. It was a complete success. But man, taking bites that small meant it was incredibly slow. With the test run complete, it was time for the main event, cutting the round build plate for the FS on S1 Pro. We chose the Glacier plate because of its versatility, and the Voron 2.4 size gave us plenty of room to work with. I measured the exact dimensions of the S1 Pro's bed and drew the circular shape with its handle tab in Fusion 360. Just to be absolutely sure, I used the same carbide bit to cut the shape out of a piece of scrap plywood first. We physically compared the wooden template against the original plate of the S1 Pro, and it was a perfect match. This also taught us a valuable lesson. Our sacrificial plywood baseboard on the CNC wasn't perfectly flat. Some parts of the circle started to scrape earlier than others, which is something we had to keep an eye on, increasing the cutting depth to account for it. Now, work holding is critical here. You cannot just clamp the corners of the thin sheet of the spring steel. If it vibrates even a fraction of a millimeter while that carbide bit is cutting, the bit will get damaged or even shatter instantly. So we used the classic machinist trick. We covered the entire underside of the build plate and the top of the baseboard with painter's tape and glued them together with super glue. Pressing it down flat, we then added our edge clamps just to be safe. Using the settings we dialed in during the test project, I did a few more dry runs to confirm the path fit the material perfectly and the tool had cleared all of our clamps. We started the job, carefully adding oil only to the areas where the bit had already removed the blue plastic coating. The machine ran around and around for 6 agonizing hours. But after the initial coating was removed, I realized we weren't making any progress. The metallic surface underneath just became incredibly shiny. And then disaster struck. Because the bit wasn't actually cutting into the metal, all the vertical force of moving the Z-axis 1.7 millimeters down went straight into the structure of the budget CNC machine. The frame flexed, the tension built up, and eventually the bit derailed in one corner, plunging violently off the path and straight into one of our metal clamps. I hit the emergency stop. Fortunately, the derailment happened on the outside of the cut, so our actual build plate was completely unharmed. The bit looked okay. We took it out and checked it with Levi under the microscope against a brand new one. Miraculously, the carbide-coated bit survived the impact, but you can see some wear compared to our identical spare. Now, the reason for our failure was clear. We tried to be too gentle. Our step down was simply too small for spring steel. Budget CNCs absolutely hate just rubbing against hard metals. Instead of grabbing a chip and cutting the material away, the bit was just rubbing against the steel, hammering it down and work hardening the surface, turning it into an impenetrable armor. Do you have any experience machining steel with a budget CNC, success or fail? I'd appreciate if you dropped a comment, but don't worry, we too had a backup plan, and how glad I am that we did. You've seen us use this Dremel to cut a hole on the bottom of our Sovolmax to add a bigger silent fan. AliExpress is honestly our go-to for workshop upgrades. It's where we source this Dremel, the digital microscope Levi's just used, and of course the BQ plates themselves before they offered to work with us. So out came the Dremel, fitted with a heavy-duty fiberglass reinforced metal cut-off disc. The CNC router hadn't managed to cut all the way through the steel, but it had scored an absolutely perfect deep track into the surface. This track acted as a stellar guide for the Dremel wheel. Notice I kept the build plate securely glued and clamped down to the CNC spoil board. I did not move it because I still had plans for the router. I intentionally stayed in the middle of the routed trail, leaving a few millimeters of material along the edge of the circle. Running the Dremel at its highest RPM of 32,000, I carefully worked my way around the circle. You have to go gradually and avoid heating up any one spot too much or you will melt the coating right off the steel. I was fully decked out in a KN95 mask, safety glasses, a hat and heavy gloves because those sparks were flying everywhere. It took about 30 to 40 minutes and I burned through 3 cutting discs on this 330mm diameter plate, but we finally cut it free. And here comes the finishing touch. With the bulk of the waste material gone, we turned the CNC router back on. We reran the exact same job, but this time with a slightly increased step down. Since the bit only had to shave off the tiny lip of remaining steel on one side, the chips could clear easily. This budget CNC machine might not be rigid enough to cut a deep slot through hardened steel, but it is absolutely phenomenal as an edge profiling tool. The bit cleaned up the circumference perfectly, leaving us with flawless factory-grade edge, something that would have been impossible with just a Dremel. We pried the plate off the wasteboard, peeled the painter's tape off the back, and took it to the bathtub to clean off all the cutting oil and steel dust using lukewarm dish soap. A final wipe down with isopropyl alcohol and it was ready. We took a deep breath Little bit drunk.
One of the best things about 3D printing, you can get drunk every day.
Just smelling the alcohol.
It sounds nice. Nice.
And does it fit the machine?
Probably not.
And drop the new custom cut PQ glacier plate into the FS on S1 Pro. It fit like a glove. We immediately ran a bad mesh calibration, and the height range came back at an unbelievable 0.16 millimeters. On a 330 millimeter plate, we fired up a test print, and the first layer and adhesion was absolutely perfect. The only casualty was my finger. I actually managed to cut myself with the scraper while removing that test print. Blood, sweat, and tears for this channel, I tell you. Only tears of joy, of course. But if this kind of dedication earns your subscription, please hit that subscribe button so you don't miss our next crazy adventure. For the absolute final finishing touch, we took our newly crafted plate over to our new Monport MOPA fiber laser. We did a few test marks on the scrap corners we had cut away, dialing in our settings, which I put up on the screen for you. And then we laser etched a custom logo right onto the handle tab, just to make it look absolutely professional. We ran a second larger test print on the completed plate, and it was a total success as well. So what were our big lessons learned today? First, if you're using a budget CNC on spring steel, don't try to be too gentle with tiny step downs. Use your first pass only to remove the plastic coating and score the outline. Do not let the bit just sit there and rub, or it will instantly work harden the surface. Second, do the heavy lifting and actual cutting with a Dremel. I probably could have saved the cutting discord too if I hadn't let the CNC harden the steel track first. And third, while the underside of our plate was perfectly protected by the tape and glue, the top surface got a few micro scratches from the metal chips and wiping away the oil. Next time, I will absolutely cover the top surface with painter's tape as well. And there will be a next time. With all this hard-earned knowledge, we are completely ready to cut a custom CryoGrip plate for the Tiny Solvo Zero. And I think we might just carve it straight out of that slightly damaged Cobra 3 plate we tore up last summer. Make sure your notification bell is turned on so you don't miss that. And feel free to share this video with a maker friend who loves modding their printers. If you want to see our initial review and the 500 watt spindle upgrade we did to this Acmer CNC router, click right here. And if you want to see the accident that started this whole adventure, watch our video on those projects here. Now let's go print 3D. Thank you for watching another gerGO Print 3D video all the way to its end. Stay safe and always have a backup plan.